Get started, folks. I'm going to record this meeting and post it on YouTube. Welcome back. So I'll remind you that there's some web work due on Wednesday. There's currently 3 due Wednesday night, although one of them is the trig formulas homework, and technically you're not supposed to finish watching that video until Thursday's class. And so I'm gonna keep it due Wednesday night right now because I'd like you to look at as much of that homework as you can for this Wednesday, but then I'll probably end up extending that one. I will extend that one till the following Wednesday. And then keep in mind, the following Wednesday, that means there'll be a whole bunch of assignments due, which is one of the reasons why I'd like to keep this one due as much as you can this week. Because we'll finish up our trig material next week, and we'll do our test on the following Thursday, the 23rd. I did get a couple questions today that we can answer. I'm also happy to go through the notes. Let me just start with one of the homework questions I had, which was about triangles. And so this is, I believe this is one of the homework assignments due Wednesday. Let me get this thing zoomed in here. Okay, so I know it's hard to see, so I will just redraw this picture and what it's asking us for. So it gives you a right triangle. This is problem number 9, as you can see. It gives you a right triangle, and it says that this angle down here is 30 degrees. And then it tells you that this side is 25, and then it wants you to find the side X.
It's a little blurry, Professor. Oh, okay, it went away.
Okay, good. And so in problems like this is where you need to use SOHCAHTOA. So I'm just going to write down the acronym, because this tells you how to relate sine to the sides, cosine, and tangent to each one of these sides. And so it depends on, remember how these problems work. It depends on what angle you're looking at and what side you want to find. And so what we have here is we're given the 30-degree angle and the hypotenuse, right? The side 25 is the hypotenuse because it's opposite the right angle. And you want to find the X, and the X is the side that's opposite the 30 degrees. And so you just think about what you have and what you want to find, and that tells you which part of SOHCAHTOA to use, right? So you want the hypotenuse, you want to use the hypotenuse and the opposite side. And so the thing that uses hypotenuse and opposite is the sine.
Is a
right.
so. Yeah.
It's the so part, exactly. And so so then this is telling you want to use sine because that uses opposite over hypotenuse. And so what you're doing is you're doing sine of the angle, and so it's sine of theta. I should have written right
so
here.
So 25 over 30.
Right, exactly. So we'll have sine of 30 degrees equals opposite, which is but be careful. So opposite is the x part, right? The x is the opposite one, so it should be x over 25. I think what you said maybe was 25 over. Did you say 25 over 30?
Yeah, that's what I said.
So the theta part is the angle, right? This theta is the angle, and then these two things are sides, right? So the 30 degrees goes inside the sine, and then the opposite and hypotenuse are the x and the 25. I'm just going to pause here and see if there are questions so far. This is not the answer, but
how you divide an invisible number into 25?
So we want to find x, right? X, we want to figure out what x is.
Right, correct.
So we know we can find out a value for sine of 30, and then we have a number 25. So we can find what x is. So we want to solve for x is what we want to do.
Right. How would that work if you don't know what x is?
We want to get x by itself, and this is going to tell us what x is. That's the whole point of this question, is trying to find out what x is. Okay. So how do we get x by itself? It's being divided by 25. So how do we get rid of dividing by 25?
Divided by 25.
X is being divided by 25. So how do we get rid of it? You multiply by 25
both sides.
on both sides. Good. Because these will cancel over here, and then X will be by itself, right? And so when you solve for X, it looks like 25 times sine of 30. And so that's a value for X, and we could even take it a step further by figuring out sine of 30, right? So 30 degrees on the unit circle is pi over 6. And we know the X and the Y value at that point, right? The X value.
You got pi over 6 from the angle of 30 degrees.
Yeah, I know that 30 degrees and pi over 6 are the same things. Let me finish this one, and then I'll answer that question. So square root of 3 over 2 comma 1/2 is the point right there. And we know that sine uses the Y value. And so for here, we use the Y value at 30 degrees, which we just decided was 1/2, right? So this really turns into 25 times 1/2. Oops, not 1 over 25. 25 times 1/2 is X. In other words, 25 over 2. And so someone had said, how do we know that 30 degrees is pi over 6? So you should know these, the main ones, basically. You should know that, I'll just drop my pen. Hold on one second. You should know that 30 degrees is pi over 6. 45 degrees is pi over 4. And 60 degrees is pi over 3. Those are the three relationships. And I mean, the other ones you should know too. Like, for example, pi over 2 is 90 degrees. I guess that's another one that you should know.
Okay, got it.
But anyway, the answer to this one, the side length X is 25 over 2, or 12.5, if you will. And so, but the point here is, and the thing I really want to emphasize is you can't use SOHCAHTOA. I mean, you can't use a squared plus b squared equals c squared, right? You can't use Pythagorean theorem on this problem because you're only given one of the sides. And so you have to focus in on SOHCAHTOA and use the SOHCAHTOA problems. That's like one of the big main parts of this course are these triangle problems. These triangle problems come up in a lot of other places, especially classes like physics or sometimes chemistry and things like that. Okay, can I answer some other questions about this particular problem? There's several in the homework like this. I definitely put questions like this on tests. Again, this is a really kind of important point that I try to make sure people know how to do when they leave pre-calc. Anything else I can help with on that right now? Okay. I did get another homework question, so we can look at the second one. And maybe, so the second homework question was from the trig formulas section. And maybe before I sort of go over that problem, let me just say something really quickly about trig formulas. And so trig formulas start on page 70 in the notes. Let me zoom out so you can see a little bit more of this. And the idea is we use these formulas, and there's a lot of them, right? So there's some on 70, there's more on 72 and 73, right? So there's a whole bunch of formulas, and the idea behind all the formulas is we can use these formulas to evaluate trig functions at kind of strange degrees, and we can also use them to prove identities. And so the thing that this question, the homework question that was asked, is sort of relating to is kind of like this problem. Let me let it focus in for a second here. So if you're asked to figure out what like cosine of 105 degrees is, 105 degrees is not one of the places we know on the unit circle, right? It's not a multiple of 30, 45, or 60. And so it's not something we know the points for, but we know that 105 degrees, you get 105 by adding 60 and 45. And 60 and 45 are both places we do know. And so you can see we take something we don't know, but we relate it to things we do know, and then we would use the formula above. So we can see that we're doing cosine of two things being added. And so then we would use this addition formula, because this tells you what to do when cosine of two things being added you have. And so that's sort of the idea behind these kind of problems, is you want to take what you're given, rewrite it in a way that lets you use a formula, and then try to get your answer to look like what it tells you here. And again, I know it's hard to read, and so I'm going to rewrite the question here. So this one says, figure out cosine of 15 degrees. It's going to look like this. So, oops. It's telling us sort of like your answer will look something like this. And it's specifically telling you, let me zoom out a little bit here. It's telling us to use the subtraction formula. So this is the problem setup. It's telling you what the answer is going to look like. It's going to look something like this, and then it wants you to enter in the a and the b. So it's going to have like square roots in it, and it's saying what's under the square root, and it's telling us to use a subtraction formula. So that's the setup. And so when we start the problem, what we want to do is we want to take cosine of 15 degrees, but we want to think about 15 degrees as something minus something else. And the two somethings should be things we know on the unit circle.
45 and 30.
Nice. So we could do 45 minus 30. Right? And so, in other words, instead of doing cosine of 15, because 15 degrees is not somewhere we know on the unit circle, right? It's between 0 and 30. We can instead do cosine of 45 minus 30. And those are places we know. And then we can use the subtraction formula. So I'm just going to put the subtraction formula up here. Right? We have something that looks like this. We have cosine with two things being subtracted. And so notice that it's an s and a t here, and the s's and the t's go on the other side of the formula inside the sines and the cosines. And so I'm going to use formula number 4 and rewrite it applying to this problem. And so I'm going to use the subtraction formula. And this becomes cosine of 45, cosine of 30, minus sine, plus sine of 45, sine of 30. And I'll just go ahead and tell you right now, I give these formulas on test, right? So I don't know these formulas. I'm looking at the formulas right now when I'm doing this. I'm not expecting you to memorize them. You just need to know how to use them. Questions so far?
So we know that we use a subtraction formula because it's cosine of 15. Is that correct? Just make sure I'm following along correctly.
I think you trailed off at the end. So you know we use the subtraction formula. I mean, this problem specifically says use the subtraction formula.
And then where do the square roots come in?
So if you when we start evaluating these things, they're going to have square roots in them.
Okay.
Other questions before we keep going? So we need to know, we need to do cosine and sine of 45 and 30. So let's think about where 45 and 30 are on the unit circle, right? 45 is right there, and then 30 degrees is right there. And we know 45 has the repeated root 2 over 2. So here's some square roots that are going to come in. And then we know 30 degrees has the point. We just did that a second ago, right? It was root 3 over 2, so there's another square root, comma 1/2. And so when we start plugging these things into there, we'll get the square roots.
I was going to say, so are we pretty much just using the x and y values for the angle for those angles? Like,
Correct.
I know cosine is like cosine of 45 is the x value and sine of 45. So it's just pretty much adding the x and y values together, right?
That's exactly right. When you do cosine of something, you use the x value. And when you do sine of something, you use the y value. And so that's why I'm writing down the x and the y value, because I'm about to plug those into the various spots here. Other thoughts before we do that? Seem okay so far? This is why we really wanted to have a good idea about the unit circle. This is what I was really trying to drive home before break and before we got all screwed up with everything. And so I hope you were able to sort of get a handle on the unit circle. If you didn't get a handle on the unit circle, you're probably confused and wondering what's going on. So I'm still willing to meet with you, still available, sitting at home with nothing else to do but talk to you about the unit circle. So if you need some help with that, let me know. Okay, so anyway, let's plug these things in. So with cosine, we use the x value, sine, we use the y value, and they're right here, right? So this is going to be root 2 over 2 times root 3 over 2 plus root 2 over 2 times 1/2. So I'm just plugging these various x's and y values into the formula, and then we simplify things down. And so this is going to be square root of 2 times square root of 3. Let's not mess that up. Let's keep it over 4. And then square root of 2 over 4. Just kind of simplifying things, right? You multiply the bottoms together. And so that looks good because we should have a 4 in the bottom in our answer. The thing we were given has a 4, and now we've got a denominator of 4. So I feel good about this. And so then we can add those two things together. And this almost looks like the answer, right? Except in the answer, something's factored out of the top, right? This square root of a is like factored out. And so I'm trying to make my answer look like this answer. And what should we factor out in order to make it look like that? What's common to both these terms?
You could figure out the 2.
Square root of 2, right? There's a square root of 2 in both terms. And so we can factor out the square root of 2. And then it becomes this, and this looks just like the answer. And so the a in the answer is square root of 2, is 2, I mean. And the b in the answer is a 3.
Yeah, little one, a 2-year-old.
I don't know if someone just tried to ask something or not, but I didn't hear it. And let me just clarify while if you're going to say something. The way that the way that a lot of web work problems go, it kind of like tells you what the answer is going to look like, and then you try to make your answer look like that, and then you enter in the parts, right? So the final answer here is entering in like what's inside the square roots, and so you would enter in a 2 and a 3. Sorry, was someone trying to ask something there a second ago?
Mister, can you move the paper over a little bit so I could see the final answer?
Yeah, he is.
Which direction? Like this way, maybe?
To the left a little bit, where you were writing.
Yeah.
Is that good?
Yeah, I got like
yes. Thank you.
Are you on a computer or a phone? I'm just curious what you're looking at.
I'm in the laptop, but it looks smaller than what it is. Than it actually was.
Yeah. I'm not really. I've tried to open up like another window on a different computer to see what it looks like, because I don't really know what it looks like here. But yeah, so in other words, just let me know if something doesn't look right. I'm gonna open something up on another computer.
If you have any chance to go over addition and subtraction formula from page 70 again.
Sure. Have other questions about this one before I take it off? So the general idea behind addition and subtraction formulas is you take something we don't know, but we write it as two things that we do know being added or subtracted. And so like in the first example on this page, let me let it focus here. Come on, focus. In the first example here, we don't know 105 degrees on the unit circle, but we do know 60 and 45. And it turns out 105 is what you get when you add those two things. And so instead of trying to think about 105, we think about 60 plus 45, right? And now we have cosine of two things being added. And so this looks a lot like this formula right here. And so that's why in this first one, we used formula number 3 because we had cosine of two things being added. And then, like, see how the formula works? It says like s plus t, but then on the right-hand side of the formula, it only has s's and t's inside the individual things. And so you write it as the sum of two things, but then those two individual things go into the pieces, right? So like on this one, S was 60 and T was 45. And so then on the right-hand side, we only have the 60s and the 45s inside sines and cosines. And each one of these things are things we know how to do on the unit circle, right? We know where 60 degrees is, we know where 45 degrees is, and so we can find those points and plug numbers into those points. Just like we just did on that last problem. It's like the exact same kind of process that we just did a second ago, just with a different formula, right? This is using formula 3, whereas the last problem we used formula 4. A similar example might be this one here. Sine of 15 degrees, right? So we could think about this a number of ways. 15 degrees is not somewhere on the unit circle we know, but 15 degrees equals 45 minus 30, and we know both those places. 15 degrees is also 150 minus 35, and we know both of those places on the unit circle. It could also be 60 minus 45. We know both of those places, right? So there's lots of sort of different ways we could approach 15 degrees. Here's 3 of them. It doesn't matter which one you choose. What's important is that you use the formula correctly. And so on this particular problem, I decided to do 45 minus 30. And so then my S is 45 and my T was 30 in the formula. And so I used this formula, the sign of two things being subtracted, with S being 45 and T being 30. So that's exactly what's going on at the bottom of this page right here. And so I'm plugging in 45 and 30 into the formula, and I know those places on the unit circle again, right? I know that at sine of 45, you use the y value. Cosine of 30, you use the x value. Cosine of 45, x value. Sine of 30, y value. And then you just simplify it down.
Question.
Sure.
I notice how you always, with the sine or cosine, let's say for this problem you have showing on right now, the sine 15 degree. It could go either way. If when you find the sine 45 minus 30, or it could go plus.
So we don't know two things on the unit circle that you could add to get 15, right? Like you could do 10 plus 5, but we don't know where 10 degrees is, and we don't know where 5 degrees is. And so,
okay, it by the unit circle.
Right, it needs to be things that we know on the unit circle that we're adding or subtracting.
Okay, that makes sense.
So, I mean, I guess technically, can anyone think? I just maybe thought of one. You could do like this. Maybe you could do sine of 15 degrees equals sine of minus 30 degrees plus 45. So that would be one, because those are both places we would know. That would be one way to use the addition formula on this, if you really wanted to make that happen. But then notice this is also the same thing as like 45 minus 30. You just switch those two things. So it's I don't know. As long as you're using the formulas correctly, there's lots of different ways to do it, I guess, is the way to think about it. But just make sure you're using things we know on the unit circle. So 30, 60, 45.
Okay. That makes sense.
Other thoughts about these addition and subtraction formulas while we're on the topic? From the notes or from homework?
What about the second problem that is going on that page? Cosine 10 minus.
This one right here?
Yes. Can you explain that?
This kind of problem is giving you the right-hand side of this and asking you to go back to the left. So like most of the time in practice, you start with something that looks like on the left-hand side, and then you rewrite it as the right-hand side, which we've done a couple times now. This problem is giving you something that looks like it's one of these things, and then you go backwards and do it on the left. So when I'm looking at this problem right here, it says cosine, cosine, minus sine, sine. And so when I'm looking up at these answers, only one of them has that form. And it's this one, right? Cosine, cosine, minus sine, sine. And so this is a formula number 3 being used, but it's giving you the right-hand side of the formula. And so this is formula number 3, like it says here. This is formula number 3 with S being 10 and T being 80. And so we're given the right-hand side, and then we go back and do it on the left-hand side. And so we take S and T, and we put them together, and we add them inside cosine. And so that's what happened here. That's why I went back to the left, and I put them inside cosine and added them. And, you know, 10 and 80 are not places we know in the unit circle. But when you add them, you get 90, which is something we know. And so it's kind of going in reverse, thinking about these formulas. And let me just say, I usually don't put formulas like this. I generally feel like I don't ask a lot of questions like this on the test. I focus more on questions that look like this, because I think this is a more applicable version of that kind of question. But there are some like this in the homework, and I will say sometimes I put like multiple choice questions that maybe look like this one. And I'll just say again, you'll have the formulas on the test. You'll have all the formulas with you. What else?
This is more of a general question. Oh, sorry, you can go first.
Oh, can we go over that last question on 71? I'm like a little lost solving it.
Sure. So the other part about these formulas is that we can use them in trig identities. And so that's what's going on page 71, is we can prove trig identities using these things. And so it sounds like you're asking about this last one here, where we want to prove that this nasty looking fraction ends up simplifying just a tangent. And so each component of the fraction is one of the formulas, right? So this is like sine of two things being added. That's formula number 1. This is sine of two things being subtracted. That's formula number 2. And when I say the numbers, I mean the ones I just showed here. So 1, 2, 3, 4, right? This is cosine of two things being added. That's formula number 3. And that's cosine of two things being subtracted. And so that's formula number 4. And so I just apply the formulas to each one of those pieces, and it ends up being this longer looking thing. And it's literally just, if you look at formulas 1, 2, 3, and 4, it's just all 4 of them kind of written out. Question so far, does that seem okay so far?
Yes.
And so what happens when you start to simplify things is that things cancel out. So like you have sine x cosine y, and then you have minus sine x cosine y. So I've just crossed those two things out. And on the top, you have cosine x sine y, and then these two minus signs will create a plus sign. And so you have two things being added, right? So those two things cancel, and then you have those two things adding together, and so you have 2 of them. That's how you get to the next numerator. And then the same thing happens on the bottom. Those two things cancel, but then these two things add together to give you 2 of them. So that's how you get to that step. And then at that step, more things cancel, right? The 2's cancel out because they're stacked on top of each other. The cosines cancel out because they're stacked on top of each other. And so you're just left with sine of y over cosine y. And we know that tangent equals sine over cosine. And so the last step there is to simplify down to tangent. Happy to clarify something about that. If there was one specific step there that was confusing, that's still confusing, let me know.
So a problem like this is you looking at it as combining like terms, right?
On this
So
step,
then
you're combining like terms, yes. This is all combining like terms
Okay.
on this step here.
Okay.
Some things cancel, some of them you have 2.
Okay. So that's always goes no matter how big the problem is, right?
Usually in these problems, you simplify at some point. And so it involves either combining like terms or crossing things out like this one. But yes, you're always combining things down. And I'll just kind of remind you the way things work. You know what the answer is, right? You're being given the answer in the problem. You're being told that this thing on the left will simplify down into tangent. And so like, you know, the last thing that you want to write down is tangent, and you know this is the first thing, right? And so you're trying to just like connect the dots between the two of them. And so keeping in mind that you want your answer to be tangent is like helpful, in other words, because when you see something like this, oh, you know that's tangent. Or even at this step, you can see like, I want this to be my answer. And so how am I going to get rid of those things, right? And so you can kind of, knowing your answer is tangent helps guide you along the way. That's sort of the way that all these problems, these identity problems work, is you know the answer, so use what you know to get you to there. I think someone was asking another question though. I'm happy to clarify this one too, but if there's another question, I'm happy to keep going too.
I just had a general question about 71. So on the video, you said that you were going to post it online, but that was to that class. Did you do it for this one too, or?
I don't remember did I not do them all in the video, or?
Yeah, you only did the middle one in the video.
So I've posted these notes are all there.
Okay.
Yes. I'm happy to look at the first one too if you want, but it's a similar application. So the first one works by just rewriting cotangent as cosine over sine. And so then this ends up being your original problem. And then you can use the subtraction formulas on each one of those things. And it's very, very similar, where you use the formulas and then things like cancel down and simplify into sine over cosine again, because you want it to be tangent. So yeah, I forgot when I did this class. I guess I didn't have time to do all these, but I did post these solutions. That should be part of that. As a reminder, I posted like a collection of all the rest of the notes in one big document in the completed class notes, I believe. Let me just double check that. Yeah, at the bottom of the completed class notes, there's a thing called remaining completed notes from trig and exponentials. And so that's what we want to be looking at. Answer some other questions?
I do have another question, but it's not about this topic.
That's fine.
I know yesterday you saw page 60, 69, 68. Is there any way you could show it again?
Let me see here.
What's going on?
Okay. So the identities you really need to be familiar with, and again, they'll be provided for you.
Can you like break it down in a different paper? Like actually do the whole steps, if you don't mind, please.
Let me just first say that like these are the ones that you really need to know, right? So these are the ones that are on page 64, especially the ones I highlighted, right? Use these most often. These are the ones I give you on a test. These are the ones you really need to know how to use. The ones on 68 are what I've labeled as hidden identities, and there's sort of like infinitely many of those. And it's just kind of like, here's another trick you can do if you get in these situations. And so I guess what I'm trying to say is, these are nice to know for homework, and they come up in the homework occasionally. I don't usually put questions on tests that require you to use these specific identities, but they are in the homework, and they can be pretty frustrating in homework and things. So we can look at those. Was there one in particular you wanted to look at on this page? Did you want to do the 68 or the 69?
This is page 69. The back.
Okay, let's look at 69. But on 69, we're going to use these identities. So maybe I'll keep this out, and then we'll do that. So I'll just work through this one on a separate page here.
Yes. Thank you.
So 69 says that this is an identity. So we want to prove that this equals this. That's our goal here. And the way that we want to approach this is you start with the more complicated side, and then you simplify it into the less complicated side. And I did it both ways in this one because when you look at both sides, they kind of both look sort of complicated in my opinion. And so it wasn't really clear which side to start with. Does anyone have a preference about which side they want to start with? Happy to look at either one. I'm going to start with the right-hand side because it's got secant and tangent, and maybe those are a little more complicated looking. I don't know. And so I'm going to put my reasoning over on the right-hand column here. So the first things you always do is you change these into sines and cosines. And so I know that secant from the identity page, secant is 1 over cosine, and I know that tangent is sine over cosine. And so you can change both of these things into sines and cosines by doing that. So this becomes 1 over cosine plus sine over cosine. Oops. And that was nice because we have a common denominator. Like, we didn't have to worry about a common denominator in this one. They both already have a common denominator. So I'm just going to add the fraction. I've just added the fraction together, kept the denominator the same, added the tops. Is that okay so far?
Yes.
So what page 68 was trying to tell us is, and at this point, like, there's not a lot else we can do, because I know the answer is going to be cosine over 1 minus sine, but like, how am I going to get there from here, right? And so page 68 was sort of telling us, if you have something that says 1 plus sine, it's helpful to multiply by 1 minus sine, because when you simplify that down, you get cosine squared. And so when you hit a dead end with 1 plus sine or 1 minus sine or 1 plus cosine or anything that's in those boxes, you should multiply by what's called the conjugate, is what 68 was telling us. And so at this point, we should take what we were stuck on and multiply by the conjugate, because that's what it tells us to do on page 68. And so I'm multiplying by the conjugate 1 minus sine. So instead of having a plus in between the two things, I put a minus. That's what it means to be the conjugate. And then what we saw on the last page is that when we do 1 plus sine times 1 minus sine, if you look on the top of page 68, that equals cosine squared. And so I know when I multiply this numerator together, I'm going to get cosine squared on the top from this property. And then I'm just going to leave the bottom alone. And why do I think that's a good idea? Why? Like, some people might be wondering, well, why didn't you multiply the cosine into the denominator?
Because you could factor out a cosine from the numerator and the denominator, and you're just left with cosine over 1 minus sine.
Right, which is the answer, right? And so I think what I think that Sean is what's pointing out is, remember what our answer is, right? The last thing we want to write down, like dot, 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 the last thing we want to write down is this, is cosine over 1 minus sine. And there's a 1 minus sine right here, right? That's going to be in the answer. And so don't mess that up, in other words. Remember knowing where we're going, knowing that this is the answer, helps guide us. And so we want this to be part of the answer. And so don't distribute that in there, because that's going to mess that up. Instead, do what Sean is suggesting, which is to cancel out a cosine, right? So you've got 2 cosines on the top and 1 on the bottom. And so this 1 on the bottom cancels one of them on the top, and you just get what we wanted. Cosine over 1 minus sine. But again, like, the thing that got us there is knowing that that was going to be the answer, right? We're told in the beginning that that's where we were headed towards. And so when we introduced this, which is part of the answer, we didn't want to mess that up. And instead, that made us realize, oh, we want to cancel one of those out, so we have that in our answer.
When we have the exam, are you going to provide us with questions like the ones on WebWork for these inverse functions? Or are you going to provide like the ones in the notes? Because the problem with WebWork, when we do a problem like this, I'm like chasing my tail because I don't know where it wants us to go.
You mean, did you say inverse, or did you mean the formula ones, or
Yeah.
or identities?
Yeah, identities. My apologies.
The identity. I'm going to ask questions like the notes, like this. Like I'm going to say, prove this, and ask you to do it however you want to do it. And lots of partial credit. Like if you change everything to sines and cosines, that's usually half the points right there. Every sort of step you take gets you closer and more partial credit. And so I think, you know, when you're doing these web work problems, what I talk about in the video, and I'll sort of mention it now, is you should be trying to work them out by hand. You know, ideally, if this was some way you could do that on a computer, I'd ask the questions like that in web work. But unfortunately, it's not a way to do that via web work. And so you have these like fill in the blank kind of things, which are not quite as good. But anyway, what I would encourage you to do is actually try to do this process when you're working on the web work, if at all possible. And I posted a lot of practice ones as well. I posted a whole bunch of practice ones that you can look at on the test topics collection of stuff. And I'm happy to look at those too. Maybe if you wanted to like practice a couple of those, maybe try some, we could look at some of those together. Answer some other questions. I appreciate you guys have been looking at the stuff, got some stuff ready to ask. Happy to keep looking at stuff or not.
Mister.
Yep.
I know you said what side you will look, what side you will start off. So if you start at that one side, how do you start off in the other side?
So if you wanted to start off on the other side, so starting with this.
Yes. And which one will be easier?
They're both similar in this particular case. If you want to start with this, there's nothing, everything's already sines and cosines, right? So literally the only thing we know how to do is this, multiply by the conjugate. And so instead of doing 1 minus sine, we multiply by 1 plus sine. For the same reason, because we know that 1 plus sine times 1 minus sine is going to end up being cosine squared. And we had no other option, right? That was the whole point of page 68, was when you get stuck on something like this, that's some way to move forward. And so when you do that, you end up getting cosine times 1 plus sine, and then cosine squared in the bottom. And then you would just keep, do you want me to keep going?
Yes, if you
Sure.
like.
Sure. So, so I would cancel a cosine now, just like we did before. So you can cancel this one with one of the ones in the bottom until you have 1 plus sine over 1 cosine, just a single cosine.
Okay.
And then let's remember what we're trying to do, right? Our final thing, the last thing we want to write down at the bottom of the page is secant plus tangent. That's what we're heading towards, right? And so that's two different things being added. And right now we have a single fraction. And so since I have two different things being added, it seems like maybe we should split this fraction up. And so this is where we could use the concept of, if you have two things being added on the top, you can split that fraction up like this. Right? Usually we do the opposite thing. Usually we have two things being added that have a common denominator, and then you can add them together, right? Usually we go like from the right side to the left side, but we could go the other way. We could have a fraction and then split it up into the common denominator. And so that means we could take this and write it like this. And oop, right away, that's our answer, because we know that secant is 1 over cosine, and we know that tangent is sine over cosine. But how did I sort of get from here to here? I needed to break up the fraction, and I knew to do that because I knew my answer needed to be two separate things. So again, knowing where I was headed, knowing that this was the answer, guided me to do some of that stuff.
Okay.
Other thoughts or questions this morning?
I have a question. This is about the upcoming test.
Sure.
What's the format like? Like you mentioned before that we were doing like pen and paper stuff. Do I need a camera or anything like that, or is this going to be digital?
So yeah, you do need a camera. What I'm going to do is send out a number of like Google Meet links, like different links to groups of people. Basically, I have a bunch of different screens, and I like to put like 4 to 6 people on each screen in my home, where I can sort of proctor and watch you answer some of these questions. You know, just as a reminder, we're doing this trig test, and like one of the main points of the trig is being able to know how to evaluate trig functions just using like basic information about a unit circle. And so in other words, I just want to make sure that you're not like looking up answers on your phone or some trig calculator or something. And so we're all gonna sort of meet online. You're gonna set your camera up so that I can see you at your desk or wherever you're writing and doing the test. I will email the test out, and you will write your answers down on a different piece of paper, so you don't need a printer. And then you will scan your answers and send them back using the Cam Scanner app. So it's a phone app that lets you take pictures, but then compiles all the pictures into one document and makes them nice looking and stuff, so I can grade them. And so just email them back to me. I will grade them digitally, like provide feedback digitally, and then return them with comments and solutions and corrections and stuff.
What's the name of the app?
The app is called Cam Scanner. I will type it into the chat right now. I would suggest you use this app in anything you need to scan with the rest of the semester in any class. I'm really trying to get all my students to use it. It's a really, really nice app that lets you, I mean, we all need to take pictures to scan things, but what it does is it crops it so it's not, you don't have like half your desk in the picture. And so we'll zoom in on your picture, and then it also takes pencil and makes it look like pen, and it basically just like makes it legible. Like, I don't know if you've ever tried to look at scan with a phone images, but it's pretty bad. And so this is a very nice solution to that. Your other professors and your other classes would thank you if you started using that thing. It's called Cam Scanner. So I'll just remind you too that I'm doing a test in my linear algebra class next Wednesday, so before we do it. And so I'm going to work out all the details with this, and I'll hopefully work out all the bugs next Wednesday, and then the following week we'll have our test, and I'll have a really good idea about how it works.
Okay, so the test is next week on Thursday.
No, it's in 2 Thursdays. It's on the 23rd.
Okay. Oh, I must have read something wrong. I thought we were having a test this week. Okay, so it's all right.
No,
So
that's what I had on. Let me just make sure. Yeah, this is my announcements page at the beginning. Thursday, the 23rd.
Okay. Yeah. All right.
And I'll just remind everyone again that I've been scanning all this stuff with Cam Scanner. Like, I'll scan the homework that I just did and everything that I wrote down and post it in the course documents as well. So you can, you come to a session late or something, you can just pop on there and check it.
I do have one more question. I don't have a printer.
So as I just said, you don't need a printer. I will email the test, and you can write down the test. You can write down your answers on another piece of paper.
Okay. All right. That makes sense. All right.
So you'll basically have the test like up on your computer or something, and then you'll just see the question, but then write the answer down somewhere else.
All right.
Other thoughts, questions? You don't need a printer, don't need a scanner. You do need a camera, ideally a computer with a camera, and a phone with a camera to scan. If either of those things are an option, let me know, and we can work something out. I think potentially getting you a computer or something like that. Anything else?
Mister, I know I mentioned in page 68 and 69.
Yep.
Do you mind if you go back to page 64?
Yep. What about page 64?
Um, so the second problem was 6x minus cos x over 10x. Yeah, that's that one, the second one. Can you explain that to me? I was looking at the notes on YouTube, but I was confusing the way you were explaining it.
So this was the introduction to identities where we're not actually proving an identity yet. We're just simplifying down an expression. So, we're just given this fraction, and we're being told to just rewrite the thing in sines and cosines and simplify. And so the work is over on the right here, right? So secant changes into 1 over cosine, tangent changes into sine over cosine. And those just come from the regular identities at the top. And so I change those things into sines and cosines. And then I'm simplifying. This is a compound fraction. And so I'm going to take the thing in the bottom there, and I'm going to flip it upside down and multiply it because it's, you're dividing by a fraction. So I take the thing in the numerator. I keep the numerator the same. But I take the denominator, and I flip it over and multiply. And then you distribute it. So it goes through the parentheses and multiplies each of those terms. And so the next line is just me rewriting this multiplied by that, right? So you have the first thing, 1 over cosine times cosine over sine. And you have cosine times cosine over sine. And again, you're just simplifying it down. The cosines cancel over here to give you 1 over sine. And the cosines multiply over here to give you cosine squared. With me so far?
Now, can you explain the second part? So you break, okay. So after you break it down equally, now that you got 1 over cosine times cosine x times cosine, that's when I get confused.
So we have 1 over cosine times cosine over sine. These are two fractions being multiplied. And then we have cosine over 1 times cosine over sine. These are also two fractions being multiplied. The way you multiply fractions is you multiply the numerators and the denominators together.
Okay.
And so cosine times 1 is cosine. Cosine times, oh, and that's not what I did here, though. I canceled out the cosines. Well, I might as well just rewrite it like this. Maybe this will help clarify it. So that's what you get in the first one. And in the second one, the cosines multiply together to give you cosine squared. Now here, you have cosine divided by cosine, and so those will just cancel, right? This cosine cancels with that cosine, and so you just have 1 over sine. What do you think?
You see, now it actually looks more facially like to understand it than how I looked at it first. No,
Okay. And so then we have a common denominator already, right? We have a sine in the bottom of both of them, so we can just do the subtraction. And then this is anytime you see the number 1 or cosine squared or sine squared, you should be thinking about sine squared plus cosine squared equals 1. And so we have 1 minus cosine squared. And so let's subtract this cosine squared over to the other side. And so you have sine squared equals 1 minus cosine squared. And so you can use this right there, right? So you can replace the 1 minus cosine squared with sine squared. And so this just becomes sine squared over sine. And then the 1 in the bottom cancels with 1 in the top. So your answer is just sine. And so the kind of the takeaway here is you started with this ugly fraction that had 3 different trig functions in it and just simplified down into just sine, right? Just one trig function. And so the value of these processes is instead of dealing with this ugly fraction, just replace it with sine and simplify your life. That's sort of what you do. That's what you end up doing in calculus a lot of the time.
Okay. Por eso te- Okay. Thank you, mister.
Any other questions?
I got a question. Why you heading to the
I think maybe someone was asking a question but got cut off. I'm not hearing anyone. I thought I heard someone say I have a question. I don't hear anyone. Maybe you should type it if you're trying to talk.
I had a question about problem number 10 on trig using degrees and triangles.
Sure. Hold on. Let me pull that one up.
Okay.
Yep.
So I have what I tried to do on screen. I don't know if you can see it or not, but I didn't know what to do with the tangent 11 degrees, which is what I had for a number, because you can't do what we were doing with the addition and subtraction. So I didn't know if the tangent 11 degrees could be like switched into something else or something like that.
Yeah. Could you just turn your maybe you're on the phone? Maybe.
Yeah.
Could you turn it sideways?
Yeah, sure. It's harder to see when you do it like that.
Well, it was sideways. Now it's not. Yeah. Okay. So you're wondering what to do about the tangent of 11 degrees, right?
Yeah.
So you should just use a calculator for that. It says in the end of that question, it says you will need to use a calculator to evaluate the trig function. So
I don't have a degree symbol on the calculator. So I tried switching it to pi, like radians, but then it gave 1.194, and then that wasn't a fraction, so I didn't know how to.
So that's probably right. So it'd be like 0.194 radians. And so you would just do tangent of 0.194 if you think your calculator only does radians.
Oh, you do tangent of 1.94. I did tangent of 11 pi over 180.
That would work too.
To get that.
Oh, I see what you're saying. Which should be fine. And then you do 0.194. Why are you multiplying it times 180 though, I guess?
Oh, why am I doing that? Did I do that?
So that's going to be multiplied
Okay.
by 5280.
Yeah. Okay, sorry, that was my mistake. Thank you.
And then I think you'll get it.
All right, thank you.
Sure. All right. Anything else? I appreciate these questions. People are starting to peter out here, which is fine. I'm happy to keep talking if anyone has anything else.
I have one, Dr. Levy.
Sure.
About the test. So you said we need a camera. Well, I have a camera, I think, but my problem is I don't have a bigger workspace to do my work. So, and I feel like if I go move somewhere else in my house, I'm going to get distracted, and I don't know what to do about it. What do you recommend on that part?
Where are you doing work in general, like usually?
I'm in my room, but my room's not a big space. It's kind of and where I have my laptop is like, I have like a small space to do anything, very small.
Is that where you're doing your homework?
Yeah, in my room, because if I go downstairs, I get distracted easily. Like I can probably show you like my room's in, like where I'm at is I apologize for that. But pretty much you can see this is where I'm having I'm working on it, and my laptop takes much space up.
So yeah, that seems like something that you might just have to work out. I don't have a good recommendation. You could potentially, I don't know how many people are in your house, and I know everyone's sort of dealing with like everyone's there with their family and there's other people around. Maybe there are kids. Maybe there's, 20 people in the kitchen and you're trying to like do work or something. I don't know the best answer. I would kind of just assume that wherever you're doing your other work, you should try to do this work. If there's something I can do to make it easier, then let me know. Like, you can take as much time as you want, for example, so you don't have to worry about like doing it in some time crunch. If there is a different time of day that might be helpful for you, maybe we could arrange to do it at another, like, for example, if you could get into the kitchen and no one's going to be there some other time.
That's the thing. I mean, my other option is because if I go downstairs, that's one thing I can just, because I'm pretty sure I can just put earbuds in or something, but at the same time, but the other thing is my printer is upstairs in my room, so it's like it's crazy.
So you shouldn't need to print anything. I'm just going to email you the test, and then you could just have it out open on your computer, and then you can write your answers just on another piece of paper, like a blank piece of paper.
All right. Yeah. I think I can try something like that.
Okay, maybe thinking about it a little bit would be helpful. And what I'd like to do in the schedule, I'm going to work on the schedule a little bit today, but I'd like to work in one of these days where there's not a movie to watch, but we just sort of practice it'll be like a review day, basically, a review for the test. And everyone will just like practice putting their camera on them so I can see them and submitting something online just so we can sort of like practice just to see if it sets up if you have a good setup for the following week.
Yeah.
So I'm thinking the day before the test or the Monday before the test, we might do that.
All right. Sounds good. Other than that, I think that's all news I concerned about.
Okay.
Thank you.
Sure. Yeah, let me know if I can help with anything else.
All right. See you Thursday.
All right. Bye.